This is our presentation for our final year Capstone project titled Alzheimer's and Parkinson's disease classification using VISARD classifier. This is prepared by me, P. Siddharth and Ashwin Pradeep. Alzheimer's and Parkinson's diseases, these pose profound challenges which impairs people's cognition, motor function, and quality of life. They carry significant burdens, including financial costs and a lack of definitive cures. And detecting these two diseases early remains a crucial challenge in healthcare. So, our research aims to evaluate machine learning based techniques, effectiveness, limitations, and potential advancements, and compare them to provide the best possible solution for detecting these diseases as early as possible. So the data set that we have used contains MRI scans from around 64,700 MRI pictures from around 50 patients with Alzheimer's disease, 25 patients with Parkinson's disease, and 25 people from healthy people. These images are pre-processed and skull stripped, and each image is also labeled with the corresponding diagnosis, that is Alzheimer's, Parkinson's, or healthy control people. So this MRI scan depicts how a person with Alzheimer's brain is different from a healthy person's brain. So we can see that the people with Alzheimer's have shrinkage in brain tissues, which is the reason for the problems that they face using Alzheimer's disease. And similar to Alzheimer's, for Parkinson's disease, the reduction in size of the putamen and caudate regions of the brain indicates Parkinson's, and these are only the very few biomarkers that are visible, and these biomarkers are only visible at later stages of the progression of this disease. So we will be using a VISARD classifier. We'll be using the VISARD classifier, which is a novel approach for classification purposes, and it is a weightless neural model which uses lookup tables to store the function computed by each neuron rather than storing it in weights of neuron connections. And the reason that we're using the VISARD classifier is because it has automatic feature learning, incremental learning, multimodal data fusion, and interpretability features, which make it a very suitable candidate for classification purposes. So the methodology for building this model includes feature extraction from the above mentioned data set of MRI scans, and the extracted features are then selected to provide the best possible features which can be used for classification purpose. And these are essentially the three major steps for building of the model. And it is further elaborated in this flow chart where it includes pre-processing, resizing the image for each pre-trained network, which is then extracted using pre-trained networks such as AlexNet, GoogleNet, ResNet 50, DenseNet 201, and VGG16. And these extracted features are then selected using J48 decision tree, which is then fed to the VISARD classifier to obtain our disease classification. This is the MATLAB code that we have used for extracting the features from our MRI dataset. In this case, we will be using the Parkinson's disease resized dataset, which contains control PD and PD subfolders, which are used as the labels for the data store. And after creating the image data store, we will be using ResNet 50 in this case to extract the layers. And from the ResNet 50 layers, we will be using the FC1000 layer in order to extract the features from. And the variables are stored in the features and labels arrays. And the code iterates through each of the images present in the data store and converts each of the images into single channel grayscale if it's already not present in the format, because the ResNet 50 model requires that the images be in grayscale in order to extract the features effectively. And once the features are all extracted, they are stored in a CSV file, which can be used for further for feature selection. This is the results of the feature extraction. This contains approximately 4,000 features and their corresponding labels. And these 4,000 features are then used for selecting the appropriate features using the J48 decision tree.
So this is the feature selection. As you can see, this is the Vector Explorer. So it's a data mining software. So we can see our classification accuracies via this software. So I'm opening the file, random file. So this I'll open the AlexNet for Parkinson's disease, and I opened it. As you can see, both the classes have the same instances, that is 450 and 450. And I'm choosing the J48 classifier because it is easier to rank the uh, features via J48 classifier. So the model has been loaded up. As you can see, the accuracy for this particular model is 69.33%, which is quite low, but this is a sample. Uh, Also, these are the rules that is been generated. So if the feature 280 is less than or equal to minus 2.83, and so like all these rules combined, we will get these particular final results. That is whether it is control PD or a person with a Parkinson disease. So let us load up the tree. Sorry, visualize tree. And this is the tree that we are getting after we run this particular model. And let me reduce size or scale. And this is the tree that we are getting. So even after feature selecting, the contributing features are more than, like, I think around 40 or 50. So we are reducing the total number of features to around 25. So we are kind of trimming the tree, so that will help us have a better efficiency in the model and have a better computation time. After the feature selection has been done, so let me open up that file which is after the feature selection, and this is the file which we get after the feature selection is being done. So we get around 25 features. So I trimmed the tree and I got around 25 features. Let me check. So 450 and 450. Now we are going to use the WiSARD classifier for and set into cross validation, and we'll run the model. We are getting around 74.77%, and uh, the training set we are getting 96.55%. We have not supplied a test set yet. So this is how we check the accuracy uh, for after the feature selection is being done. And also we need to split the data set into two, that is training and test split. So we have already done that. Let me just select the file. So I'm inputting the training set. There is also 36 features here, and I'm including the test set. So now I'm running the WiSARD classifier, and we are getting around 88.14%. So this is the maximum accuracy that we got for Parkinson's disease, and this is also sample to just show how we are using VECA, how we can see the classification accuracy of each models.